So welcome to CSIS 45. My name is Alex Stoikov. I'm going to be teaching the class this semester. I've been teaching it for a long time. So if you go to the iLearn website, you're going to see this class webpage, hopefully. If you don't, let me know. In there, we have the class times and days. There's two sections. There's the Monday section and the Thursday section. I cover the same material twice. So if you missed one, you can go to the other one. If you want to hear it twice, come to both. If you're in the online section, you're welcome to come to any of these. And if you're in any of these, you're not required to attend because I don't take attendance. Okay? The way I'm going to measure your attendance is through the class webpage. If you logged in, you're attending. If you turned in the assignments, you're attending. Otherwise, you might get dropped. You may fail the class. Okay? There's a welcome message. Let's go through this real quick. And in there it tells you that, this is the first programming class, C++1, my name, all that good stuff. And the main thing is, if you're going to contact me, send me an email, include CSIS 45 in the subject of your email and the assignment number. If you're asking about a specific assignment, that's my email. It's also on the main class webpage. You can also message me through here, but prefer if you send me an email. It's easier to reply with files and attachments. This does not support that for some reason. Turning in assignments, usually 7 days after they were assigned, turn them in. Ideally, turn in the assignments that were assigned this week by the end of this week so that we can, when we talk about next week, it makes sense, okay? If you don't keep up, you are going to fail this class. Treat it like a math class, okay? It's not going to be super hard if you keep up with the work, and it's going to be impossible if you don't, okay? Hey, so, textbook, there's a couple of textbooks that I have listed on the syllabus. None of them are required. You can get them for extra reference, or if you have some free money, somehow get the books for a good reference. Everything that you need is going to be on the class webpage, and I provide you with whatever you need to succeed in this class. That's one. If you turn in things late, don't worry about it too much. I don't like taking points off for things being late. So if you turn it in by the end of the semester, I'll grade it for full credit. But if something's wrong with the assignment, I also offer you a free regrade. So you turn in the assignment, you didn't do well, I took some points off, I left you feedback. If you fix the assignment according to the feedback and resubmit it, I'll give you full credit for it. Okay? But that's not going to happen if you wait until like the last 2-3 weeks of class. Alright? I'm not going to do that in the last couple weeks of class. So it's important for you to keep up. If you turned it in earlier, it's pretty much set up so you can get an A in this class. If you don't get an A in this class, it's because you're lazy. Okay? I don't care what the excuse is. Okay, you got work, you got whatever. Find the time. Okay? Put in the time, come to class. I have plenty of office hours. Come see me. Send me emails if you get stuck on something. I'll get back to you within 24 hours on the weekdays, 48 hours on the weekends, usually much faster than that. Okay? That's one thing. The other thing is your grades, or mainly the gradebook. Okay, so I'm going to go to Student View, and I'm going to click Grades, and you're going to see this thing the same way you would be seeing it. Right? So it shows like this. This is the gradebook, and by default, it will not show you your correct grade. You need to click on this little checkbox so that it actually shows you your true grade. Like right now, I have 0% in this class. Okay, what this will do if it's enabled is, let's say we have 70 assignments in the semester, you turned in 3 of them, and you got an A in all of them. This thing is going to tell you have an A in the class, which you don't. Okay, so turn this little thing off so that you know what your true grade is. Okay, that's one, and that's good for now. So you can look through the syllabus, all that good stuff that I just told you pretty much is in there. Told you about attendance, told you about due dates. Okay, so first of all, the class webpage, is this. It's broken down into different weeks. I got to work on these two. I haven't finished those yet. Okay, there'll be some files and classes thrown in there. We have plenty of assignments. There's something like, I think, 7 assignments every week, which isn't too bad, but you have to keep up with them. Okay, and at some point here and there, I'm gonna have like 1 week where you do extra credit towards the end. I'm gonna do a couple of weeks where you can catch up and do these kind of things. For the regrade that I told you, every assignment that you are required to turn in this class, you're welcome to turn it in twice. First time, if something's wrong with it, you can resubmit it. Second time, fix it, get full credit for it. For the midterm, if you didn't get 100% on the midterm, you're welcome to resubmit the midterm, and I'll give you 50% of your lost points back. Okay, same thing with the final. However, you're welcome to show me the midterm before you submit it and tell me, hey, does this look good to you? That's also good, right? You don't have to resubmit it. Just show me what it looks like in the beginning. I tell you, yeah, it looks good. Turn it in. You got 100. Okay? So this is the way for you to get an A in the class. Yeah, just you take advantage of what I offer. All right, so that's the resubmitting and submitting things. Now going to week 1. Okay, so I'm assuming that you're either doing this on Windows or a Mac. If you're working on a Linux, I'm sure you can figure out how to install C++ and use C++ on Linux. Okay, there's instructions on how to install code blocks on Windows. If you have Windows, Google code blocks. You go to codeblocks.org. There's downloads. You want to go to the binary releases, and you want to get this one right here, the one that says MinGW setup. Right? You install this thing, and unless you have some kind of an antivirus that messes with your computer, it will work, and you can write and run programs in it. Okay? If you have a Mac, this is not going to work on a Mac very well. They have a Mac version, but it's like 6 years old, or at least 5 years old. So we're not going to use this for a Mac. What you can use for a Mac is something called CLion. And you can go to JetBrains, just Google JetBrains Student. Okay? JetBrains Student, free for students. You click on this little thing here. You go to this little button, click it, apply now, okay? And you put your first name, your last name, your email address. The email address has to be your gavilan.edu email, okay? Any .edu email will do the magic. They send you a free license for a whole year. The software costs like $200. You get it for free from them, plus all their other software that is available through JetBrains, which is like $1,000 worth of software. For 1 year, while you're a student, at the end of that year, you can renew the license for as long as you're in college. Okay? They offer really good products, and if anything's wrong with the CLion, which is the program we're going to use, then you can just easily contact their tech support and tell them this isn't working, and they'll help you. I've done it. Okay? And they're helpful. So get your license, and then once you get your license, you basically just install CLion. If you're going to be doing this on a Windows, it's a little bit more complicated. You have to download and install something else. So I'm just going to assume you're using code blocks if you're on Windows, and you're only going to go do the CLion if you're on a Mac. If you need extra instructions, I'm not sure if it's here. Did I put the MinGW instructions? No, that's just the Mac. Yeah, just follow these instructions on how to install this thing on the Mac. Once it's installed, then the program is, it's not open. Oh, there it is. This is CLion. Okay. And what I'm going to do is I'm going to create a new project. Well, actually, you just do this. You go File, New Project. It's a C++ executable. You just give a name for that project. I called my project CSAS 4045 Fall 2017, and then when you hit the create, then it'll create something like this. All right, this is my project name. There's a C make list. Don't worry about that. There's a main CPP. The main CPP is where we're going to write all of our code. Okay, so this is where I'm going to write the code, and I'm going to erase all this stuff here, or most of it. Okay, so first of all, why don't I do this? I'm going to cut this, put it here for now. Okay, so I guess I'm going to just jump straight to showing you a C++ program. All right, so the C++ programs we're going to write are going to have a couple of things, include IOStream, and using namespace std, then there's going to be an int main, and then a cout hello, and that should do the magic for now. Let's just leave it like that. There. Okay, so in any programming language, the first thing you should do is show some kind of a message out of your program. The message that I'm going to show is hello. When I press the little triangle here in CLion, then you're going to see the little message right here on the bottom, right? Okay, if you're doing this in code blocks on Windows, there's going to be like, when you run the program, there's going to be like a little dialog box that shows up, okay? And that's where the program is going to run, not in here on the bottom. Okay, if you're using CLion on Windows, then it will look exactly the same. Okay, so this is your program. So this is the template for every program. You need to have this include IOStream and using namespace std so that you can show messages. The way you show messages in C++ is using the cout less than. This int main business here, that is just where the program starts. Okay, we're going to get into details about what it is. It's actually a function. Okay, and that function we'll learn about later what a function is. Okay, but this is where the program starts. So I'm going to go back to the class webpage. So that was the getting started business, programming, indentation, comments, grading. Let me look at chapter 1. I'm not going to. So there's some PowerPoints from one of the textbooks. This is one of them. It talks about hardware and software, programming languages. So there's going to be a quiz next week. And again, by quiz, it's just like a multiple choice thing. You can take it online, unlimited number of attempts. If you take it once and you don't like your score, take it again. Okay? But all the answers are in the Savage textbook or the Savage PowerPoint, not the textbook. You don't need the textbook. Okay? So programs, languages, compile, interpret. Let me see this. All right, that's a good one. All right. So there's different programming languages out there. There's high-level languages. There's low-level languages. Python is one of the highest-paid programming languages, by the way, right now. Right after Java in Silicon Valley, you can make a lot of money if you know Python. And of course, if you have a degree in computer science. Okay. So first of all, programming languages, low-level languages. If you look at if you have a Windows computer and you open up like one of the programs that are there, they're going to be an executable program, right? You open that thing with a text editor and you're going to see something like this, right? Just a bunch of nonsense symbols. These are basically the machine instructions and the closest we can translate them into a human language, if you want to call it that. Okay, so basically an executable file is just a bunch of ones and zeros. On or off is the only thing that a computer can understand. So those are the kind of instructions that is in the executable. Ones and zeros. We don't write in this. Nobody writes machine language, really. The one language that we write in is the one that's a little bit higher than that, which is the assembly language. Okay, so for assembly language, if you look at assembly language, is something like this, right? So this is an example of a low-level programming language where you're literally telling it how to move information into the processor from RAM, then from the processor into RAM. Fortunately for you, you don't have to worry about this kind of stuff because we're going to be dealing with a higher level language. The example that I have here on the right is Python. Python is an even more higher level language than C++. Okay, so This here is a human-like instruction, a single line of code. It's easier to understand. Okay. This here is a wall of text, and it's a lot more difficult to write, a lot more things for it to go wrong. Okay. So we, generally speaking, don't like writing in assembly. Okay. We write in higher level languages like Python, like C++. Python is really a high-level language versus C is kind of like a mid. C and C++ are mid-level because they allow you to look at the hardware level also. So you have a lot more power with C++, but with that comes messier code and more things that could go wrong. Okay, so that's what I said. So high-level languages resemble human-like words. The instructions are, like print, show this, do this, loop, that kind of stuff. Low-level languages are, assembly, very tedious. Okay, the way the C++ programs work is we're going to write our programs, then there's going to be a software code compiler which is going to turn our code, which is the little hello world that I had, it's going to create it, turn it into an object code. The object code then gets linked by a linker into a final executable. And the final executable is something like your Windows calculator. You just click it and it works. Okay? So for a compiled language, you basically have a final program and you can just open it. It's a standalone program. For an interpreted language like Java, like Python, there isn't a final executable file. The process kind of stops at the object code level, and there's another software called a virtual machine which goes and reads the object code line by line and then executes it line by line. So in order for you to run an interpreted language, for example Java, if you want to run a Java program, you have to have Java installed. If you want to run a Python program, you have to have Python installed. If you want to run a C++ program, you just run the program. There's nothing to be installed. Okay, so compiled languages like C++ are faster than interpreted languages. Interpreted languages like Java are more portable. They can run across multiple computer platforms. Okay. So common parts of your programs, and first of all, what are programs? Instructions for the machine to do something, right? Basically, it breaks down into input, what kind of information is going to go into your program, some kind of processing. Your program is going to think about what information went into it, and there's going to be output. We're going to show the information that got into the program, or we're going to do something with it and show it. Hey. Okay, so bugs, any kind of a problem with your code is a bug. Fixing it is called debugging. Okay, there's different kinds of errors that can, different things that can go wrong with your program. One of them is a syntax error. So syntax, this language, the C++ language, has rules. For example, every line is supposed to end with a semicolon, right? Every statement, or most of the statements. If I take out the semicolon and I try to compile and run my code, you're going to get some kind of an error message like this, right? Sometimes it will tell you, expected semicolon. So you will know what's wrong with it. And sometimes there's going to be like some weird error that's not going to tell you anything meaningful. All right, let's try this one. Run. Now it's saying something. Yeah, see, now there's a different error. Result of comparison against the string literal is unspecified. So it's basically thinking that you're trying to compare this to this with the less than sign. Right? So sometimes these syntax errors are going to be meaningful. Sometimes they're going to be total garbage. You want to make sure that you understand the error messages and how to fix them. Okay? And you want to make sure that you follow the syntax. Syntax errors will prevent your program from running. Okay? There's also runtime errors, and you're going to have a lot more runtime errors with C++ than you did with Python and some of these other languages. Runtime error is the program runs, but it's not working the way you thought it would, right? Sometimes it might crash. Sometimes it might run unexpectedly, okay? A lot of times expect things to be crashing and not working the way you want them to in C++. Okay, other more user-friendly languages like Python, like Java, will give you the error much earlier, right? They'll prevent the program from running with the error. this is an old school language, things are not going to work, okay, if you don't write them exactly as they should be written. Okay, so that's a little bit of information, a little bit of the terminology of different kinds of errors, all that good stuff. And then, yeah, programs, there are more in there that I can look at. Yeah, and there's like a little more explanation of what's what. You can read it. All right, so you should have an idea at this point of how to install code blocks and get it to work on Windows, or if you're on a Mac, use CLion, right? How to compile and run in code blocks. I have a video for that. You can watch that. It's slightly different than how I do it in CLion. All right, so now the next things that I want to talk about are comments. All right, so this is my standard C++ template, right? Right. This is my program. This is where it starts. Okay, and now what I'm going to do is I'm going to write some comments. Okay, so at the very least, so first of all, what are comments? Comment is this. Okay, anything that starts with 2 forward slashes. Okay, and I can put a comment right here, says this is output, which is information comes out of the program, right? And if I run my program, run it again, it will still show me my little hello world or hello without, you know, even though I typed a bunch of extra stuff in there, these things, the comments do not affect your code, right? So comments are not considered part of your program or code, all right? So they don't affect the actual program. Comments are just explanation for your code or documentation. Okay, so at the very least, I would like you to have your program name, program number. So every programming assignment is numbered P1, P2, P3, right? Program number, let's say this is P0, that's CPP. Then we're going to put your name, right? Put your name in there, put the date started and finished. If you did it on the one day, just put one day. What's today? 08/31/17. And description. Okay, what is the program supposed to do? Okay, so whatever you see me type up, I'm going to save this file and I'm going to upload it for you. Those are your lecture notes. I'm also recording this as a video, and I'm going to post the video also. All right, so don't worry if you can't type up everything or if you can't follow. You know, if you can't follow, let me know, but don't worry about having to type everything up. That being said, it's good for you to take notes, because if you write, you actually retain the information better than just watching me type it. Just so you know. Okay, so on top of your programs, so these comments are these 4 lines of comments are worth 30% of your grade. So if you just forgot to go in there and type up this stuff in your programs, you lost 30%. Okay? Another 30% of your grade is to show me how the program ran. Right? How does the program run? Well, right here on the bottom. Right? This is how the program runs. I'm going to copy this piece. Then I'm going to go to the bottom of my code. I'm going to do /*. And these here are called multi-line comments. Multi-line comments, which is just like a comment, but you don't have to type in // in front of every line. Everything that's in between these two, you know, /*, */ is considered a comment. So multi-line comments show how your program ran. This is going to be another 30% of your grade. So if you forgot this piece on the bottom, you lost 30% of your grade. If you forgot this piece on top, you lost 30% of your grade. So you can have a very long program that you took a long time writing it, and you turned it in without the comments, and you lost 60%. All right? And of course, you get to resubmit it, but then that's more work for me, more work for you. So get it right the first time, please. Okay? Comments on top, comments on the bottom, and then some code in the middle. So that's the format to submit assignments. And we know what comments are, we know what output is, information that comes out of the program. Comments are just explanations for your code. And what else? Okay, so I guess I gotta tell you about the different kinds of information. All right, different types of information are also known as data types. Okay, so what are the different kinds of information that we can store in the computer? Okay, we have whole numbers, we have decimal numbers, we have characters, we have text. Leave it at that. Okay, so the whole numbers are integers. So whole number is integer. Okay, decimal numbers are either floats or doubles. Okay, characters are like anything in single quotes. Okay, and text is anything in double quotes. Okay, so these are the kinds of information that we can store into our programs. Okay, and I'll give you some examples. So, man, I'm going to run out of juice. Jaron, do you have your charger by any chance? Can I get it?
Camtasia's sucking up the battery. Looks like it's 75% right now.
All right, now we're safe. So, different kinds of information can be stored into our computers using variables. Okay, variables are words we make up to store information in memory, or we make up to refer to places in memory where information is stored. Okay, so the example that I like to give is, let's say you have, we're talking about internet addresses like Google, right? Google has an IP address. A set of, I don't know how many numbers, maybe 12 numbers, okay, and they're changing all the time, or every once in a while they're changing. It's much easier for you to remember google.com than it is for you to remember a set of 12 digits that change all the time. So that's basically what variables are. Just words that are associated with some number in memory, okay, some location in memory. Okay, so let's say, for example, let's start with the numbers. Okay, numbers. So we're gonna do int age, right? Okay, this here is, so let's do it this way. I'm gonna do it this way. So this is going to be data type, and this one here is going to be variable name. Okay, so the data type here, this is an integer. All right, and then I'm going to have a float, let's say weight. All right, this is a decimal. I'm going to have also a double. All right, I don't know, I'll call it E. All right, it's some engineering constant. This is also decimal. All right, and then I'm going to have, what else do I have? Char. I'll call this letter. All right, this is a character. And then string. String is, I don't know, text. This is a string. Okay? So what I am doing here is, this is called declaring a variable. Declaring variables. Okay? Which is basically reserving these words as variable names and of specific data type. Okay, so this is one way that C++ is different than Python, for example, some of the other languages, is that you're declaring the variable age to be an integer, and it can only be an integer for the duration of the program. You cannot change age to be of any other data type. So if I want to make age to be a string later on, error. Okay, if you want to try to get the age to be a float, can't do it. Okay, so it is reserved to be an integer, and it's going to be an integer for the rest of the program. Can't change it. So that's it. So what I'm doing is basically I'm declaring these different words to be of specific data type, so that the program knows that, hey, if I ever use a weight, it's going to be a variable where a decimal number is going to be stored. Okay, so this is declaring the variables, and what I'm going to do underneath is I'm going to initialize the variables. All right, so I'm going to say, all right, well, age is equal to 9, weight is equal to, I don't know, 10.5. Forgot my semicolon. My E is, I wish I knew what the freaking constant is. I think they change. Whatever. E is equal to 1.2345, right? Okay, so both of these, float and double, they both represent weight. I mean, they represent a decimal number. Double is just, you're allowed to use twice as many bits to store the information. Like character, I think it's 4 bits. Float is 8 bits. It's not 8 bits, but the number of bits that are used in memory. So first of all, bit is the smallest piece of information that the computer can store. It's either on or off. 8 bits are bytes, right? And it goes in multiples of 8 basically. So integer is 4 bytes. I think character is 2 bytes. Float is, I think, 8 bytes. Double is 16. Okay, don't quote me on that. It's the information is on the web page. Okay, the moral of the story is float is a shorter decimal number. Double is twice as long. Okay, so if you want a really long decimal to be stored on your program, use a double. If it's a little shorter, use a float. Okay, and I have all the little details of which one is how much. Let's see if it's in here. Variables, input and variables. Yeah, I guess variables are later. Okay, next week, more details. All right, so these are my variable names, initializing the variables, making them equal to some value. Let's do a character. So letter is equal to A, right? Single characters. Text is equal to hello world, right? So this is initializing the variables. All right, so unlike other programming languages, you need to initialize your variables or the language will not initialize them for you. Like Python and Java are nice. If you have a variable and you haven't given it an initial value, a lot of times it will make it equal to 0 or null or that kind of stuff. Not C++. All you're going to do is you're going to tell it, okay, there's some place in memory where this variable is going to refer to, and then if you try to use the variable without giving it an initial value, the number that could be inside my age variable could be anything. In fact, let's check it out. I'm going to go in there, I'm going to do a cout age equals age, right? So what I'm doing is, by the way, endl means show a new line. So this piece is used to insert a new line. Okay, so we're going to show the hello, then we're going to insert, basically hit the enter key, and then the next thing is going to show underneath it. Okay, and what's the next thing? Well, I'm going to show you the age, so let's run it. And oh, perfect example. What's the value stored inside age? 32767. So I didn't give it a value. That's whatever's in memory. That's whatever value was left in memory that age is referring to. Okay? So garbage. If you do not initialize the variables, because values in them will be garbage. And by garbage I mean a number like 32767, right? That's what's being shown at this point. So I have not made the variable age equal to this. This here shows 32767. It sometimes could be some even uglier number than that. Really long. Okay? Now I'm gonna initialize the variable age. I'm gonna do a cout age equals age endl. I'm going to run my program again, and age is equal to 9, right? So I changed the value. That's why it's called a variable, because the contents of it vary. Okay? So far so good? Still awake? Awesome. All right, so these are the basics. So this is the different kinds of information that we can store into our programs using variables. Didn't tell you about the rules for the variable names. Okay, so what I'm going to do this is, in here, is I'm going to tell you rules for variable names. Okay, and they're very similar across different languages. First one is can't start with a number. So I cannot go in there and I put a number right in there. Okay, if I tried that, it will give you a syntax error right here. Right? It doesn't like that. If I go and I fix it, then program runs. Right? Runs fine. Okay, so can't start with a number in the beginning. You could put a number here, you can put a number at the end, no problem. Okay? Why do you think this one now is being highlighted as red? It's never declared. So I changed my variable name here to A1GE1, and now it doesn't know what this one is. So if you don't have a variable declared, if I don't have a variable called age declared any longer, I have a variable called this. So that means I have to go in there and I have to update my names everywhere if I wanted to change this one. Okay, but let's not. I'm going to fix it like this. All right, and now it's fine, right? And by the way, this red highlight thing only appears in CLion. If you're using CodeBox on Windows, you're not going to get to see this. It will still show you a similar error message. Like if I do this, right? This is red in CLion, but I can still try to run my program, and then I'm going to get an error message. All right? This is the kind of error message that you're going to get from CodeBox in Windows. Okay? And what is it saying? Use of undeclared identifier age. So it kind of tells you what's wrong with it. It's undeclared age, right? So I didn't go and declare an age. I need to fix this. Now it's declared as age. Okay? So that's another example of a syntax error. Something's wrong with the program, and it's so wrong that it can't even run the program. Okay? So it's a syntax error. What else? What else? What else? So can't start with a number. Can't have spaces. So I cannot go in there and do this. Doesn't like it, right? the first error is going to be right here. Then the second error is, oh, I don't have an age anymore. And that leads me to that, one of the important things in C++, debugging, fixing your bugs, start at the top, right? So if, for example, if I run my program, let me run it again, you're going to see that there's a lot of errors. It says 4 different errors generated. There isn't 4 errors. Well, I mean, I guess technically there are 4 errors. There's one here, one here, one here. But if I fix the topmost one first, fixes all the other errors, right? So always go at the topmost error, fix that first, then recompile your code again, try to run the program again, and then it works. Okay, so if there's 100 errors, fix the first, run again. Right? If there's 50 left, fix the first, run again. Okay. So can have spaces. Third one is no special characters like these. None of that stuff. Okay? Only special character, only underscore is allowed. That's the only special character you get to use. So if I go in there and I have string first name, alright, I can capitalize the first letter of every subsequent word, or I can do this business. That's fine too. But I cannot do this. Alright? Or I cannot do this kind of stuff. Okay, no special characters, no spaces, you can do the underscore. Okay? Underscore is just if you want to connect different words. Yeah, just to make it look better. So you can do it with the underscore, or you can do it like this. So both of these naming conventions are widely used.
Is there a syntax rule for C++ for formatting, for the code formatting? Do they prefer camel case or?
No, you can see it either way. Yeah.
Doesn't matter.
No, doesn't matter. Okay, generally speaking, start the letters, start the variables with lowercase. I guess constant can be uppercase. Generally speaking, uppercase things will be for classes. So we're not going to touch classes for a while. So basically, variables, try to make them start with a lowercase, even though I kind of broke the rule a couple of times here. All right, they're not fixed. Okay, so anyway, the rules for variable names: can't start with a number, can't have a space, no special characters except the underscore. Right, only underscore is allowed. Another one is no, can't use reserved words. Can't use reserved words, such as cout, right? Not a good idea to use a cout as a variable, or char, or int, right? Or any of these other ones that turn orange, right? Or whatever the color code block shows you. Okay? So char, int, float, double, right? What other ones do we learn? We also have main, using, namespace, include, right? Generally speaking, you don't want to be using these as variable names, but anything else goes. Okay? And then last but not least is use meaningful variable names. What does that mean? Well, if I go in there and if I'm talking about an age, don't call it num1. If I'm talking about weight, don't call it num2. If I'm talking about whatever that engineering constant is, don't call it num3, because it'll be much harder for you to figure out what variable is supposed to hold what kind of information. Okay? So make it easy for yourself. So when you're reading and writing your code, if you use meaningful variable names, it makes it easier for you. Questions? So far, so good? Okay. So we know about output. Information comes out of the program. We know the different data types, or the different kinds of information that's stored in the program. We know about the variable names, which are words that we use to put that information in somewhere in memory and refer to it by these names. We know about the rules of these variable names. We know how to show the variables, right? When I do a cout and then put something in quotes, that's the label, right? So this is the label here. Label, capital label. Right? And then I have the actual content of my variable. Right? Content of stored in the variable. Right? So this one thing here showed age is equal to something else. Okay. So initializing variables, very important. Otherwise, you're going to get garbage numbers like this 32767. And yeah, comments on the bottom of your code to show how the program ran. All right, so if this is the program, I copy this thing. You can copy the whole thing if you want. Let's just copy it up to there and then paste it in there. Okay, again, it shows me that you tested your program, you did the good job, it works, and if you don't have this, you lose 30%. These are the comments that are, spread throughout your code. You don't have to write them, but I highly recommend for you to write them at least in the beginning. When you're doing something for the first time, explain yourself with as many comments as you want how the thing is working, right? Cout is how we show output, right? Just like I'm writing comments in there. Okay, so I guess I'm not writing enough comments. So cout is how we show output in C++. Okay, so this is the output, and now the next thing that I'm going to tell you is input. Okay, input is information that goes into the program. Okay, so how do we do input? Well, I'm going to use some of these variables here. So I'm going to say, all right, cout, enter a new value for age. Okay, cin age. This here is my input. So just like we do output in Python and C++ using cout less than, we do input using cin greater than using cin, right? This is, you already know, information that goes into the program. Okay, we can also get information into the program from a file, but this is an information from the keyboard. Okay, using cin this way, we can get information from the keyboards. If I spell it right, close enough. All right. So there's different kinds of input. You can have a touch screen. You can have some sensor reading data and throwing, entering it into your program. You can, store the information into a file and read it from the file. All right. Different ways to input information into the program. What we're going to be doing is we're going to be entering information using the keyboard. Okay. So let's have a look at this program. If I run it, notice how before when I had my program, when I didn't have the cin, if I just commented out, by the way, that's an easy way for you to turn off your code, pieces of your code, just put 2 forward slashes in front of them. If I run this, program finishes, process finished with exit code 0. Okay, so that means program ended. If I take this out and I run it, it's kind of hanging in there. It's not doing anything. So what is it waiting? Well, it's waiting for me to enter a new value for age. So 55. Hit it. Okay, now it finished. Okay, so you enter some information, you hit the enter key. As soon as you do that, the information gets stored into this variable, and then we can show it. Cout, you entered age, and L. Okay, run again, enter new value for age, 56, you entered 56. Okay, so I entered the two values, hit the enter key. As soon as I do that, the information gets stored into my variable age, and then I show it to you. Make sense? Any questions? We're all good? All right. So, and this is how you're going to be doing the input for anything. So, if you want to enter a string, it's slightly different. So I'm not really going to focus a whole lot of time on strings in C++ because it's not a very string-friendly language, unlike Python. Okay? So I'm going to kind of ignore this data type, the string and the character, for a while. Okay? But if you wanted to enter information like a character, a single character, or a number, integer, float, or double, same way you do an input. So let's do another one. And this time I'm going to do, by the way, this message right here, this first cout. Whoops. So this piece here, this is called a prompt. And what is a prompt? Well, you tell the user what to enter, right? Tell the user what to enter. If you don't have a prompt, what do you think is going to happen? What if I just take this out? The user wouldn't know what to do. If I run the program and now it's just like this, it looks like it's frozen. Am I supposed to enter something? I don't know. There's no input, there's no prompt to guide me, okay? So moral of the story is provide good prompts so that the user knows what to enter, okay? Maybe enter a new value for age. Maybe I want to tell them enter a new integer value, right? Because what if the user decided to go enter a decimal value into age? What did I declare age as? Age is an integer, right? Which means only a whole number can be stored in it, right? That's what an integer is. So let's try it. I'm going to run this thing. New integer value for age. I'm going to give it a 3.99. And now when they hit the enter, what do you think is going to show me for age? So age is supposed to be a whole number. I'm giving it a 3.99, which is a decimal. What am I going to get? Good guess. If it was Python, you would get a syntax error. But this is C++, so it will just not work for you. So how is it not going to work? Is it going to give me a 3 or a 4? Okay, good guess. Let's try. 3.99. Okay, so if you're trying to put a decimal into an integer, it just deletes all the decimal pieces. It does not round up. It just always rounds down. Okay, so that's one of the things that could happen with integer arithmetic and that kind of things. Okay, so and by the way, this is why it's very important for you to show the information that you entered. So immediately after I entered 3.99, I'm showing to myself that, oh wait, I didn't really get a 3.99, so it's not working. I don't have to go and do some equations and then realize down the line that, wait, this program is not working. Why? Because I forgot to declare the thing as the right data type. Okay? And again, this illustrates kind of like the painfulness of C++. If this was Python, it will give you an error. It will tell you, no, you can't enter an integer into a float into an integer. Now, that'll be an actual error that stops your program from working. C++ just doesn't work. Okay? And there's a whole bunch of these that happen. And actually, that's why I kind of think that this is a very important language to learn on top of Python, because Python teaches you, kind of like bad habits. You kind of expect the language to handle things for you, but in the real C++ or C world, or even assembly, which is worse, it doesn't work out that way. Anyway, so input variables, prompt, why prompt is a good thing, why you need to have a good prompt, right? How if you entered a float or a decimal or double into an integer variable age, you end up losing the decimals. Okay. I guess I'm gonna do some more input. Let's do input of float so you can see it. Input of a float. Which one was the float? The weight, I guess. Cout. I can do this. I can say weight equals weight. Enter a new value. All right. So I can show the old value and have the user enter a new one. Then I'm going to show CN weight and then cout you entered weight. Okay, run the program again. And it's a new value for h, whatever, 1. Weight is equal to 10.5, right? That's the old value that I had in weight. Enter a new one, 99. I'm entering an integer, right? That's okay. I can enter an integer into a decimal, no harm done. Okay, and that's it. So input of a float / double, same thing. Okay, if you want to do a character, same thing. Input of a character, it was called letter. So cout, enter a new letter. Cn, L, cout, what's letter? Letter equals letter, and L. Alright, run it again. And 1, 3, letter P. Alright, there you go. So that's how you do input of letters. Question?
When you entered the weight,
Yeah.
as just a regular integer, even though it's a float, is that 3 still a float?
It's
Or
a
is it
float.
converted?
It's a float. It shows it as an integer, but it's a float. You remember, if you declared something as a float or a decimal,
Staying that way.
it's staying that way for the rest of all eternity. All right, it is what it is. Okay. So that's that. So input information goes into the program, and one little thing that I want to show you about integer arithmetic thing. All right. So integer arithmetic, if I can spell it. There you go. Okay, so let's say I want to do this. I want to do cout 3 divided by 4 is equal to 3 divided by 4, just like that. And what is this going to show me? I guess you can do the calculator business. 3 divided by 4 is 0.75. Is it going to show me 0.75? Should. Well, let's find out. Run the program. I'm gonna have to enter a bunch of stuff first. 3 divided by 4 is 0. Oops. Welcome to C++ world. Okay, so why is it doing that? So this here shows as 0. Why? Because it thinks, or C++ thinks that since you are dividing one integer by another integer, then result should also be integer. Okay? So how do you think I can correct this problem? Yep. So I'm just going to grab this thing. This is your fix. I'm going to do this 0.0, 0.0, 0.0, 0.0. Okay, and run again. All right, so there you go. That one works. 0.75. Yes? Okay. So be careful of this kind of stuff because you can have some really nice long formula and there's an integer division in there and it doesn't work. Okay? If you have 0 times a bunch of things, you're going to end up with a 0 no matter what. Okay? So, going back to the class page and data types, integer, double, floats. Oh yeah, there you go. That's the information for the different data types. So I was lying to you. Int char is 1 byte, int is 4 bytes, float is 4 bytes, double is 8 bytes. Okay? And just to give you a little idea, why is this thing going from 128 to 127? Okay, let's have a look. So, because we have time. And what I'm going to do here is show you, first of all, bit, right? Smallest piece of information, which is either 0 or 1, right? 1 is on, 0 is usually off, right? 1 is true, 0 is false, right? It's got different meanings, but whatever. It's either 1 or 0, okay? So what does that mean? Let's say if I have, this is my bit. Bit is this, okay? So the information that can be in this is either 0 or 1, okay? So how do you think I'm going to represent the number 2 then? So this is bit. We'll call this binary. And we'll call this decimal. Okay? So if I have 1 bit, this is 0 decimal, and this is my 1 decimal. Okay? So if I wanted to do 2 bits, if I wanted to do the number 2 decimal, I can't do it with a single digit in binary. Right? The binary number system has just the 2 numbers, 0 and 1. Our decimal number system has 10, 0 through 9. And don't worry, I'm going to go in way more detail about this stuff later, but just so you know what a bit is and byte is. Okay? So then if I wanted to do 2 of them, 1, 2, a little space in there. Right? So then this one here, the first one could be 0, then 0, then you can have a 0, 1. Right? So this one here is decimal 0. This one here is decimal 1. So how am I going to get a decimal 2, you think? 1, 1? 1, 1 is actually 3. So basically...
No, 0, 1 is 2.
No, 0, 1 is 1. 1, 0 is 2. Yeah, 1, 0 is 2. So if I wanted to add 1 here, it's just kind of like the carrying in decimal we do. So I wanted to add 1 to this. This is going to become 0. Then we're going to carry the 1 over to this side. So then if I say 1, 0, this is decimal 2. Right? Then if I do 1, 1, this is decimal 3. Okay? And basically the way it works out, and again, don't worry, I have a special assignment just for this next week. Okay? But you're getting an early introduction to it. All right? So let's say if I had 1, 2, 3, 4, 5, 6, 7, 8. All right? This here is 8 bits, which is equal to 1 byte. Okay? So, bless you. Okay, so basically, if I go and I say, and the way it works out is this. This first one here is 1. All right, maybe I should put, oops, crap. All right, this one is 1, this one is 2, this one is 4, right? It's kind of a pain to do this, but whatever. All right, this one is 8. All right, this one is 16. Damn it, no, it's really not going to work. You're enjoying this, aren't you? Okay, and then what else we got? 32. All right, this one here is, what do you think? 64. They just doubles up conveniently every time. Okay, and this one here is 128. Okay. So actually the biggest number that we can have in here is you go in there and you add up all these different ones. If I turn this whole thing into, if I turn this into 1, 1, 1, 1, 1, 1, 1, 1, then this is basically going to be 128 plus 64 plus all the way, right? Let me write the whole thing. Plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. All right, let me try to calculate this thing. All right, what number do we get? 255. All right, so the largest number that you can represent using 8 bits is 255. But because we actually use one of these to signify whether this thing is a positive or a negative, right? Then we can't really use all of the 8 bits. We can only use 7 of the bits, right? And if you add up all these here, if you add up these here, this here, this is equal to, what do you think? 1 what?
27.
It's 127. It's basically one number less than this one. If you add up all these here, you're going to get 127. You add one more, and then you get this one. Okay? Anyway, and that is the reason why these integers go to negative 128 to 127. The negative 128 is two's complements, is how you convert binary to decimal, or how you show the sign in binary numbers. One thing to point out is that, and so that's the reason why char can only hold this range of values, right? 127 makes sense. The negative 128 is because this is how we show a sign. Okay. Another important thing to point out is the decimal numbers are not easily shown in binary, because you only have zeros and ones. You run into the same issue how you have irrational numbers in decimals. Anyone know what a irrational number is? It's like pi, right? It's like pi is like 3.14 blah 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 something. You know, there is no repeatable pattern in the 3.14. It just keeps going, and you can't round it exactly to what it should be, right? If you have 3.1555555 and it's always 55, or if you have 3.123123123123, there's some kind of a repeatable pattern in the decimal. An irrational number in our decimals cannot be exactly written, right? So you can round the pi to some number of digits, but it's never going to be exactly accurate. And the same idea is why we cannot represent decimal numbers exactly in binary. So if you have some kind of a program and you're doing decimal things, and all of a sudden you're like, wait, what? Adding a million ones doesn't give me a freaking decimal, right? Well, yeah, but maybe you try to add them, they're all floats, and you try to add a bunch of, kind of rounded representations of a 1. And because of that, so decimal, basically math with decimals is never really exactly accurate in computer science because of the binary number representation. Okay, when you take my CSS 46 class, I'll go in depth about this, right? The floating point representation discrepancies, right? But now you know, right? The main thing that you need to get from this is, what is a byte? It's 8 bits. What's a bit? It's 1 or a 0. Why is this thing? Well, I guess you should kind of understand why one byte is only 127. Well, it's because, remember, 1 byte is 8 bits, but we're not really using the first bit, because the first bit is going to be used to signify whether it's a positive or negative number. And then when you add up only these here, these bits here on the bottom, the biggest thing you can get is a 127. And again, don't worry, I'm going to have a special thing just for converting between these two number systems. I'm also going to show you hexadecimal and all that good stuff. Okay, so that's that, and I'm almost done. So, I have some lectures from previous semesters. This is from the summer when I taught this class. This is the lecture that I'm doing on Mondays. I think yours is a little better because I already did one this week. Plus I had to do Python right before this class, and I'm really warmed up. So whichever one you want to watch, I'm sure they're not exactly the same because I don't know if you can tell, but I'm winging this most of the time. So that's that. All the information is in here. And then what I'm going to do now is I'm just going to go through these assignments, and if any of you need any extra clues, I'll give you extra clues. I'll try to go do extra clues even if you don't say you need them. Okay. So first, a couple of extra credit assignments. One talks about well, let's look at it. So this is the first one. There's a book in there in PDF that you can get for free, and it's talking about Moore's Law, and has processor speed followed Moore's Law since 2001? If not, why are processors faster? So first of all, do you know what Moore's Law is? What's
the increase in
transistors?
I think it had something to do with bits. I know it increases every I don't remember. I took Mr. Parker's class at CHS last year, and I remember the name.
Okay, so Moore's Law is, what is it, Zach?
Like the capability that we have grows as time goes.
So the capability of computers grows as time grows. So basically, the observation that Moore, it's not a law really, it's an observation. This guy Moore observed that every couple of years, it's actually less than every couple of years, we can pack twice as many transistors on the same surface space. And that allows us to double up the speed of processors, and technology doubles up in speed every couple of years. Right? So it gets to the point where, this little thing that's in your pocket used to be the entire building in the 80s. And I'm not even kidding. And it was 1,000,000 times more expensive, 1,000,000 times bigger. So that's the exponential growth of technology, kind of, sort of. But it has not really been observed since the 2001. Okay, we have kind of reached the plateau of how many, with the current technology, we can pack in a certain surface space. But now they're overcoming those limitations by packing more of them, right? More and going in vertical and going in 3D space, figuring out different ways to build them out of graphene, out of making quantum processors and that kind of stuff. So basically, this kind of law, it gets to the point where we reach the limitation of one technology, but then we come up with, invent some other technology that allows us to overcome that. Question?
Yeah, what was it? The double amount of transistors within a what?
In the surface space, and same amount, yeah, you double up the amount of transistors you can put in the same amount of space. And you can read this thing here and tell me why processors are going faster. That's your first extra credit. If you don't do it, it doesn't count against you. If you do it, read it, write a little paragraph, and you got free 10 points. Okay? The next one is the singularity that this crazy guy, Ray Kurzweil, was predicting. And I guess you just need to go watch this new movie called, old movie called Ghost in the Shell. Any of you seen that? I just watched it in the airplane when I was flying from Europe. And that's what this guy's predicting. So he's predicting that technology in the not so distant future is going to be growing exponentially faster and faster. It builds on itself. So it just takes off faster and faster, and it gets to the point where around 2050, you can no longer keep up with the technology unless you yourself enhance yourself with that technology, or you become Android. or whatever you want to call it. Cyborg, sorry. Is it Cyborg or Android? I don't know. Cyborg, there you go. All right, so I mean, and when you think about it, why wouldn't you? If you're competing for work or whatever it is with somebody who can just learn a language in a couple of seconds, you're at a disadvantage. So I don't know, but that's what this guy's prediction is. By 2025, actually, he predicts that the AI will be as smart as a human being in terms of like written conversation. So you can go online, and there's a lot of bots already. I think on the Slack thing that I got just the other day, there's a bot that answers you questions and stuff like that. And they get better and better, right? So by 2025, his prediction is that you will not be able to tell the difference whether it's a human being or AI that you're chatting with. Okay, so watch this guy's predictions. Tell me what you think about them. If you want to get all philosophical about it, I don't care. Just write something. Tell me what you think. Okay. If you don't think that's true, I'll be laughing at it, but I'll give you credit. Okay. So that's the extra credit stuff. All right. Then there are some sample programs in there. Okay. Type up sample C++ program in this PowerPoint, and then save and submit your program as this name and show the output, right? So this is the PowerPoint. Wait for it. Okay, there's a whole lot of pages. You don't have to read through all of them because I do such an awesome job explaining what's what. But you can read through them, a little more detail about what I said. And towards the bottom, wait for it, eventually, one day. Come on, how many pages are there? Show you where it ends. Testing, debugging. There you go. So when you see this is the end of the chapter, and after that there's different displays. Look for display 1.8, and there's going to be a sample program in there from the book, and type up this sample program, right? It actually asks you to, you have a couple of variables in there. You're going to ask the user to enter 2 pieces of information, 2 integer values, and then you're going to show their sum or something, or product. Okay, so type up the program, get it to work, make sure you include comments on top, comments on the bottom, tell me which one's what program is this, your name, the date, right, description, and show me the test run. So this little gray box, that's your multi-line comment on the bottom. Okay, any questions on this? All right, easy enough. The next one, so that's the P1, P2, print CS. Yes, it's similar like the Python class. So you basically get this information, this piece of message, and show it on with your program. How are you going to do that? Here's your little hint. All right. So this is your P2 hint. All right. So you get this stuff. You're just going to go in there and you're going to do a cout, quotes, and L. And you can pretty much copy this first line, this first. Right, and you do this for all of them. And I'm not going to do it for all of them. You do the rest. Right, you do the rest. This one here I think needs extra space. There you go. Might have to play around with it a little bit. Anyway, this here, instead of an endl, I can do \n. So I'll do \n, quote, right? And a little comment, \n is the same as endl. Okay, same way. Same thing to, 2 different ways to do the same thing. And then after that, I'm just going to copy this piece, paste it at the end of each of these lines. And then when I run my program, this thing should look like a the top of a CNS. All right, so run, and there's the CNS. Okay, so you got to do the rest of the lines. So that's your P2. P3, I have a sample input program. So again, the format, some comments on top, program description. Then you have the actual program. It will look better on your computer screen. It's just the resolution that looks messed up. And then what it's supposed to look like at the bottom, you can change the information in there. You can change the weight, you can change the height. You can type in your name, right? You don't have to copy my stuff if you don't want to. Okay, so that's your example program to get you started with input. Okay, and then P3B is write a C++ program that reads in two integers and then outputs both their sum and their product. So your first program, the P1, was an example that showed you how to enter two numbers and find their sum, or I can't remember, the product. This one asks you to do both the sum and the product. So just use the P1 program to do this one. Make sense? All right. So I'm going to write that little thing here. So P3 hint, is this P3? Whoops. So P3 hint, use your P1 as a starting point. Okay, and P1 was just type up a sample program. Next one, P4. I actually have made a little video for this to show you how to do stuff, and I'll show you this again. So basically what it is this is similar to the other one that we had, right? Remember the one that showed you these things? Okay, except this time, this is your P4, is it P4? P4 hint. All right, you basically start with this, right? This is what we're going for. Let me move this. So I'll do the same thing as before, cout this, and maybe a little space. There you go. And then do the backslash and quotes for these. And I'm going to erase this. Okay. Now the next thing is, what I want to do is, I'm not going to be showing the X every time I run this. What I'm going to do is, I'm going to ask the user to enter a letter. So I'm going to do, let's say, char L, cout, enter a letter, cn L, damn it, L. Right, and then what I'm going to do is I'm going to replace these here with whatever the user enters. Great. Okay. So what I'm going to do is I'm going to put quotes before and after each of these. Actually, let's do it this way. Quotes there, less than, quotes here with around this extra space that I have, less than. So this space here, I'm going to put quotes around it. All right, less than here, less than there, and then less than here, quotes in there. And I'm going to change the X to L, which is the variable name, L. Okay, this one here, there's two of them. So I'm going to try to put quotes right in front of it. And I do less than, less than. This whole space that I have, I'm going to put quotes around it. Quotes here, quotes there, less than, the X, less than, quotes there. Then I change the X to L. Okay, and then hopefully now if it's all been lined up nice and neat, see what it looks like. So 1, 1, 1. There's your CS. Now enter a letter. Letter is A. And there you go. Now it's going to make us the big letter C out of little a's. Okay? Just a little more practice with input. If you get stuck, look at the videos, look at my notes. Okay? Last one, or second to last. Draw a picture program. There's an example of a picture of a triangle. Flip it upside down, make it a rectangle, make it a circle. I don't care, just play around with the output. Make another program. Last one, 2 output programs. So first one is write a program that shows as many different words as you can think of that can be formed using only the letters in crate. So just a couple C outs with different words. That's it. Okay, you don't have to write a program to do this. Just show output. Okay. Write a program that draws a picture of a spaceship. So you already saw a picture of a triangle. Make a spaceship if you can. If you don't want to, you can write a program that shows the longest palindrome you know. A palindrome is a word that you can spell the same way back and forward. Okay? So civic, noon, right? Examples of palindromes. So I guess Google the longest one, do a C out, and you're done. Okay? That's that. And to submit assignments, let me go back. Let me double check this real quick. So yeah, that was the P6. All right, so to submit assignment, this is what I would do. So you have your code. If you're writing this stuff in CLion, all right, CLion, you don't want to be making new projects every time. What I would do to say, keep you from, doing extra work is, so this is my program. Let me just copy this whole thing, right? This is how my program ran. I'm going to paste this right here at the bottom. I'm almost done, right? So I'm going to get this whole thing, copy this, right? Go in there, select all, Control A, Control C, copy that thing. Open a text editor like Sublime, for example. Paste that stuff in there, all right? Sublime works on any platform, Windows, Linux, Mac, save as. This is my P0 CPP. Right, I'm going to save it on the desktop. Save. This is my program. Right, P0 CPP. I'm going to go in there, submit assignment, choose file, P0 CPP. Make sure you give me the CPP file. Don't give me the .o or the .exe. Okay, otherwise I can't see your source code and you get a 0. Okay. Open, submit the assignment, and that's basically it. Okay? If for some reason you decide to resubmit this assignment, right? Or maybe the assignment, the program, your assignment has a couple of pieces in it. You submit one and you decide to submit the other one, you're no longer going to be able to see the original submission because Canvas sucks. That's just the way it is. All right, and I have complained about it. I even plan on getting on the academic senate so I can, shoot this stupid idea down if I can, and make them switch to something else. But for the time being, if you submit, new work, your old work will be hidden from you. That's just the way it is. I can't turn it off. I can't disable it. I can see your work, all of it that you've turned in, but you can't. Why? If you figure it out, you let me know. Okay? And that's it. That's all I have for today. Sorry for keeping you 3 minutes, 4 minutes extra. Thanks for coming. Keep coming. Don't miss lectures.
CS meeting today?
Well, not according to the president.
I know. Is there a meeting today? What time?
What Tuesday? Is it Tuesdays?
Thursdays.
Was it Thursdays or Tuesdays? Thursdays. But we have to change the time because I have.
That sounds like what time?
Because there's a class here until we're at Thursday right now. You guys, all of you should join the computer science club. There's a computer science club. That's the president's right there. If you join, extra credit. It will look good on the resume. All right. So, what's up?
I just had a question. I'm actually buying a laptop soon,
Uh-huh.
and I was wondering if there's like any recommendation, which you
Sure.
thought was easier, or was Windows